you can hear me.
Edward, yes, we can.
Thank you very much, Amelia. Um, I do have to give a disclaimer that we're using a new platform. We were together last year, so you will be familiar with these collaborate sessions, but we are now in Teams, first of all, and then you are using Moodle, which has come with its own challenges, but we are trying to sort everything out just so you have a smooth experience with the module. Hopefully, it would be um, as smooth as the previous one. Maybe hopefully by the end of Unit 1 or as we go into Unit 2. But I'd like to just welcome all of you to this module, and I'm very excited to see all of you back again and working with us in this module. So we will be looking at slightly more focused content in terms of what we're doing. So what we did in the unit, not the unit, but the module A was more of laying the groundwork for us to work on these financial concepts in your textbook. So you will see that a lot of what we're going to do is chapter 5, and that is going to be important for you to just grasp the concepts. And I'm quite excited about what we're going to be doing. um, I am experimenting with allowing people to unmute themselves, so please just bear with me. With Teams, I think it might help us a little bit better to just, if someone has a question, to just speak what their question is and not type it, because I found that with Teams sometimes there's a delay with the chat room. So please feel free to use the chat room or to unmute yourself. I'm just going to see how it works in this session. I tried it with the A module just now, and I found that I spent slightly more time working on the work because people were speaking as well. But we'll see how it goes. All right. So we are going to be um, looking at sections 5.1 and 5.3, and coincidentally, it's questions 2, 4, 8, and 12 for both sections. And then in the next unit collaborate session, we're going to be looking at section 5.2. So we do skip a session, and I'll explain why just now. I'm just going to mute myself for now. Just want to sort out some settings. Just give me a moment, and then we'll start. All right. Um, I'm going to start now. I'm already recording the session in case you want to refer back to the work that we are doing. And then for those that would have missed the session as well, for them to also have a look at the work that we do. But I do encourage collaboration and interactive sessions as always. I'm sure you already know that. So we'll get started. Is everyone okay at this point in time? Are there any issues that we need to sort out beforehand, before we start? A thumbs up, okay? That's good. All right, so we'll get started. Chapter 5 is really us having a look at the mathematics of finance. So 5.1 is compound interest, and 5.3 is interest compounded continuously. So we found it to work a little bit better to skip section 5.2, which is the present value, because it gives us the basis for the sections to follow. So these three sections do work hand in hand. We just take 5.1 and 5.3 first together, and then we put 5.2 right next to all the later sections that we do afterwards. So don't feel alarmed or anything if you think I might have missed a section. We'll do 5.2 in unit 2. Right. So as usual, we will look at the first problem for 5.1, which is problem number 2, which is asking us to find two things. Firstly, the compound amount and the compound interest for the given investment and rate. So when we say rate, we're talking about an interest rate, right? So if we have a look at question or problem number 2, we are given $750 for 12 months at an effective rate of 7%. Now, what we are being asked to find is, firstly, in part A, the compound amount. So this is like a future value, right? So if you remember, the formula would be, or if you've have had a look at your textbook or the recordings, the formula would be the future value or the compound amount is equal to your principal times 1 plus the interest rate to the power of n. All right, so here we are looking for this guy. So part A is looking for that, and then part B is looking for the compound interest for the given investment and interest rate. That's not given in this formula. It's actually let me just highlight that or underline that compound interest. It's actually asking us for what is the interest, right? So if you say you start with, so you start with a certain amount P and then you end with a certain amount S, what is I that you have gained? All right, so hopefully you understand the reasoning behind that. So we'll start with our principal amount. We'll say we had $750, right? So 750. So we're looking for part A, right? 750 is equal to 1 plus our interest rate is 7%. So that would be 0.07. Just apologies, my pen is not really the greatest. So I look like I can't write, but my handwriting is really not this bad. Um, Anyway, so how many years? So it says 12 months. So it's 1 year. So it's just to the power of 1. So this is in years. Okay. So if we do this calculation, we will find S. All right. And can someone do this calculation and post it in the chat room and tell me what answer they get? If we start with $750 and increase it with 1 plus 7% for 1 year, how much do you get? Here we're assuming we're working with dollars, so I'm just going to write dollars. You can just let me know in the chat room. I'll start a little bit slow for the first couple of questions, and then I'll keep speed the pace up. All I don't. Oh, all right. Thank you very much. We do have an answer. So Aisha, and then Amelia, you have a question. Yes, do go ahead.
Okay, listen, I was just trying to figure out how to get this thing to type because it wasn't giving me. Yes, I got the same answer. It wasn't giving me
The same
place to
answer.
type it.
Oh, okay. Well done. Okay. So sometimes raising your hand does become a challenge a little bit. I don't know why that happens because I had a challenge raising my hand as well earlier this week. But I'm glad you got the same answer, and it is actually the correct answer. So thank you, Aisha, Amelia, and Pomelelo. So the answer is actually, if you put that into your calculator, you get 802.5. All right. So now the question that I want to ask you is, how much interest do you think we have gained from this investment? If we started with $750 and then we ended up with $802.50. All right. How much interest is there? Right? So you will see that it is actually 5250, and that is very correct. What you've done, I'm assuming, is you've taken the difference between these two amounts, right? Because 802 is the amount that you got in the future, 750 is the amount that you started with, and the interest is intuitively the difference between the two. So I will now like to just review the solution and see. First of all, $802.50 is correct. And then now for us to calculate the interest, we need to get the difference between our future value and our present value. And then that gives us our interest amount, which you so rightly confirmed as $52.50. Right. So thank you very much for that. Now we go on to the next problem. So the next problem is problem number 4 in the same section, section 5.1. We are asked to find the effective rate to 3 decimal places that corresponds to the given nominal rate, right? So we are given 5% that is compounded quarterly. We need to compare this, right? This is what we call a nominal rate. Nominal rate. Okay. What we want to find is the effective rate. If your bank was to say, we give you an interest compounded quarterly, and you wanted to find, well, what's the interest that I actually get per year? This is the conversion that we would need to do, right? So that you understand the finance of it all, right? So we are told we are given 5% compounded quarterly, and then we want to go and find the effective rate. So we know that the effect, I don't know if you've seen what your textbook says, the effective rate is essentially 1 plus the nominal rate divided by the number of times that you compound the nominal rate to the power of the number of times that you compound it, and then you minus 1. So this is very similar to the compound interest formula, if you can see. So that's how I remember it, right? So if we were to substitute everything that we have, we would have 1 plus, what's our nominal? It is 5%, so 0.05. In some calculators, you can actually write 5%, and I'm actually quite happy for you to do that. You can do that. I'm not going to stop you from doing that. So 0.05 over quarterly. How many times do you compound if you say quarterly? Is it 1 or 2 or 3 or 4 or 12 or 365 or what? If it's quarterly, how many times do you do it? 4. Well done. That's quick. Thank you very much for answering. 4. So that's quite unanimous. Zoe, Amelia, Pumlelo. Okay, thank you. So that's 4. And then we have a 4 there, and then we minus 1. If we do this calculation, I know I'm putting you guys on the spot, but I do encourage interaction. So I will just ask maybe one more time for what this calculation gives us, and then for the next couple of questions, I'll speed it up a little bit because I can see you guys are engaging, right? We have a good group, even from last year. So what answer do we get here? Okay, people are typing. All right. I should have warned you guys to have your calculators next to you. I'm sure someone is running to the next room to find their calculator because then Edward is making people calculate things. Okay, we've got a couple of people typing. I just want to give them a chance. Okay, so the answer is correct. And I will caution you to give me me running. Yes, I will caution you to give me all the decimal points that you find because the answer that we get is a decimal and we actually need a percentage. So remember, the percentage you will end up multiplying by 100. So if you get a decimal point that has 0.05, give me the next maybe 3 numbers, just so we are sure of what's happening, right? Because yes, that's better, right? So remember 5% and 5.09%, if we are looking at maybe a mortgage or a repayment of some sort, it's quite significant. The difference is quite significant. So it is actually your second answer. So 5, let me write the decimal first. So 0.0509, and I'm quite a stickler for these things. I'm going to go to the next decimal place, 0.095. So unless if you're told how many decimal places we're going to want, then you can stop at a certain point, and this would give us 5.095%, right? So let's have a look at what the solution says. Okay, it is indeed 5.095%. Right. So if you were told to do it to 2 decimal places, it would actually be, if you have 5.095, it would be to your next decimal point. But anyways, here I didn't specify, so I can take even 5%. But then if it is specified, please stick to that. Right, so let's have a look at the next question. Now we're going to do a question that has 4 parts, right? So, and when I say 4 parts, it actually has, oh, here's a question.
Sorry. Just before this year, so the question asks for 3 decimal places, right? Is it 3 decimal places in a
Oh,
nominal
3
place?
decimal places. Yes, yes, yes,
Yeah,
yes.
so is it like 5 point and then 3 after that?
So, yeah, so thank you very much for picking that up. So when it says 3 decimal places, it's actually in the percentage format, which is why
Okay,
I went
okay,
to
okay,
that
okay.
next number. Yeah. Thanks,
Okay,
Aisha.
no problem. Thanks for clear.
Right. Yeah. So our answer will be in decimal format, but please make sure when you multiply by 100, you do get your 3 decimal places. Right. So this is me like doing this thing for a couple of times. I was saying, oh, if you're told how many decimal places, and I didn't even read, right? So the importance of reading. They say if you want someone to know something, just put it in writing. They will never read it. Right. Right. So the next problem is problem number 8 of 5.1. So we're still in that section, and it's asking us to find I think two things. The compound interest, that's the first thing. And then the second thing is the effective rate to 4 decimal places. So now I'm going to pay special attention. So it says 4 decimal places if, and then they tell us the amount and the interest. So this is just like the first two questions combined, because the first question asks us for the compound interest. And then the second question asks us for the effective rate. So now we just put the two together and we can do that, right? So we are told that 1,000 is invested for 1 year. Already 1 year says N is equal to 1. Okay. 1,000 is invested tells us P is 1,000. And then annual rate of 5%. So this is R. Now, part A says quarterly, so M would be equal to, we did this one already before, so this is before. Monthly, what would be M be equal to? Quickly in the chat room. Excellent. I like that. And then weekly, 52, excellent. And then daily, what would that be? All right. Okay. Thank you. So, Aisha, thanks for actually saying or something, because we do have leap years. So in this module, unless otherwise specified, we're going to just assume we're going to ignore leap years. So here we'll just take 365. Otherwise, we have to say 365 and a quarter days, right? So we will definitely specify to you if we're going to take leap years into account. But just to simplify things, we're just going to say a year has 365 days. So that's a very good point that you put up there, because it allowed me to make that note. So let's have a look at that question. Problem 8, then if we have a look at the first problem, right? So we want to find the interest. The interest, we must, compound interest, we must first of all, like we did before, I don't think I need to go back to that problem, but we first of all calculated the future amount, right? And we did this by P times 1 plus R over M, and then that's M times N, right? We did this. Find that one was future value equal to present value 1 plus R to the power of N. Here, now we have compounding. That's why I'm putting this M and M, right? I think your lecturer likes to say November, and can't remember what he says for M, but yeah, so those are the two formulas, which is actually the same formula, right? So this is the compound amount. The compound interest, we found earlier that it was just the difference between S and P. So if we take this as S, you would say, okay, S is P 1 plus R over M to the power of Mn, and then we minusing P, right? So if I factor, we did factoring, right? Just now in the A module as P, then this would be, okay, we don't need to simplify this. We can do this in one go. It's fine. I'll just use it like this. So this is the interest. This is part A that we're looking for, right? Compound interest. All right. And then effective rate we've done before. We've done the formula before. We know that the effective rate is 1 plus, it's always this part of the formula, right? And then the nominal over m to the power of m minus 1. So that's just the calculation that we need to redo in this case. Okay, I don't know if anyone is brave to do the first one, and then the rest of the ones we can look at together. So what is someone to do? What is the interest, the compound interest for part A, and someone to do what is the effective rate for part A, right? If we do it quarterly, we have 1,000 Rand as our principal amount, and we have 5% compounded quarterly for part A as our interest. Okay, so I'm looking for part A, part 1 for now. I'm just encouraging you to do the calculations on your own. I've written down the solutions already, but I think it's more beneficial for you to try and put the stuff in your calculator than just for me to show you answers, because I will post this stuff for you anyways afterwards. I see, Amelia, you still have your hand raised. Was it for the previous question, or you have an additional one? All right, it's down now. Okay, so part A, I'm assuming it's part 1, and that is correct. So the question wants us to do effective compound interest. So remember, compound interest is money, right? So how many decimal places are you going to make that? When they count money for you, it's always to how many decimal places? 2. Perfect. So you're going to say $50.95. Okay, excellent. Well done. And then the effective, someone to do the effective rate. Now this one, the effective rate, I do want it to 4 decimal places as a percentage. Okay. Okay, that is excellent. Thank you very much. Okay, I'm hoping that everyone else who's calculating at least got the same answers, especially for the first part, because the first part is actually the calculation that leads us to the second part. Because effective rate just comes from the interest amount. If you find the interest amount, you've actually found the effective rate, because it's just divided by 100, right? Okay. So I do have one more person typing, so I'm just going to allow them to answer, and then we'll move on to the solutions. So we found that for the first part, those 2 answers were correct. We did get $50.95 for the compound interest and 5.0945% as our effective interest rate. The calculation that we did is exactly the formula that we used before. So if we use the same formula for the next parts, when m is 12, we'll find that we will just put 12 here and 12 there. Same amount is 1,000. Same interest rate is 5%. And then we'd find $51.16 in the second one. And then 5.1162%. And then on the next one, we would find $51.25 for compounded weekly, and then that interest rate. And then if we compound annually, we would find $51.27. And I want you to notice something just as you go and consider investment options. If you have the same interest rate that is compounded, let's say quarterly, and then you compare it to the same interest rate that is compounded weekly, and so on. If you increase the number of compounding periods, you increase the effective rate, right? So that can actually help you to choose what investment option you want to do. So this actually shows we get an interest of $50.95, and just shy of $51 here, just shy of more than $51 here, slightly more than $51, and it's like $51.25 here, $51.27. So it increases the more we compound. All right, cool. So please, if you are feeling shy or anything, do drop me an email, but I'm sure you know by now that I'm happy to answer emails should you have an issue. Now we're looking at problem number 12, and it's saying find how many years it would take to double a principal at the given effective rate, and give your answer to 1 decimal place. So here's an instruction that we need to adhere to. But the question is actually, how many years would it take to double a principal at the given effective rate? There you have an investment goal. You want to invest a certain amount of money, and you're saying to yourself, I want to double this money. And you are given an effective rate of 5% compounded annually. And you want to find out, just when will I double this? Will I still be alive? Is it in my lifetime, or maybe my child will be too old for them to actually benefit from this? You can make those decisions, right? So we are given 5% compounded annually, and we need to find out how long would it take to double it, right? So the equation we would use is, okay, to get the amount that we can get in the future, it's S, and the amount that we start with now is P. This is multiplied by 1 plus our effective interest rate to the power of n. And n is the number of years. So that's the unknown in the equation, right? So if we are given, let's check what we're given, right? We are not given any amount. Am I wanting to double 10 Rand to become 20 Rand? So maybe I wanted not only to buy one Coke, but to buy 2 Cokes. Or do I want to double 100,000 Rand to make it 200,000 Rand? So it seems like that amount doesn't matter, right? So if we start with P, what does the future amount become if we are doubling? What is S equal to if we make P double? Thank you. 2P. So S is equal to, let me just erase the question mark, 2P. Right? So it's like exactly, we've known each other for a while, and you finish my sentence before I even finish asking the question, right? So S is equal to 2P. So we're going to go put 2P there. So 2P is equal to P times 1 plus R to the power of N. So you will see that it does not matter what principal you start with because the P's cancel. Now, all we'll need to know is the interest rate, which is given as 5%. So now we can go and put this as 2 is equal to 1 plus 0.05 to the power of n. And we need to solve for n. Now, because of the first module that you've done, you have tools to allow you to find n, right? That's where logs come in, and we're going to use them now. So I'm going to go, since I'm out of space there, I'm going to go to solution, exactly what we've spoken about. S is equal to 2p, and then 2 is equal to 1 plus r to the power n. For us to get to n, we apply logs both sides. So I'm going to write there, apply logs both sides. Okay, and naturally, I'm going to use the natural logarithm. You can also use like log, but we prefer to use ln, right? We've done ln in the past. We prefer to use ln because it is the direct opposite of the exponential function, which we use a lot. So if you put a ln here, you would need to put a ln there. And we know with the rules of logarithms, if you put a ln there, the exponent comes down. So it becomes n ln whatever the bracket was. And then the exponent has come down already, right? And then that's ln 2. And then now you can find n by dividing both sides by ln of 1 plus r. And then you say ln 2 over ln 1 plus r, of which we know what r is. It's just 0.05. If you put that into the calculator, ln 2 over ln 1 plus 0.05 gives you 14.2. And this is n, right? N is always given in years. Okay, 14.2 years. Just out of interest sake, if the question is said, how many years and months, right, would need to come back here and say, this is 14 years, 0.2 years is how many months? So you say 0.2 of a year is 0.2 times 12 months. You do that calculation, 0.2 times 12, you find that how many months that is, and so on. But here we just asked for years. So you can say 14.2 years, right? Okay, everyone happy so far? Okay, thank you. Right. Let's have a look at problem number 2, which is asking us in section 5.3 now. It's asking us find the compound amount and compound interest if 4,000 is invested for 6 years and interest is compounded continuously at the given annual rate. Now we are shifting. Please make your mind shift from compounding like compound interest to compounding continuously. Continuously now means we're moving on to the exponential formula. It's like you're not compounding quarterly, you're not compounding monthly, you're not compounding weekly, you're not compounding daily, you're not compounding hourly, you're compounding continuously, right? So that goes to the exponential formula, which is given in your textbook as well. So now we know that if we compound continuously, I think you might have seen this before, the future amount is equal to your present amount times, it's not 1 plus r to the power of n anymore, it is e to the power of your interest rate times the number of years. Okay, So this is compounding continuously. So now we just want to find the compound amount, which is S, and compound interest, which is just I, the difference between S and P, which is easy to get. If 4,000 is invested, so this is P, and then for 6 years, this is N, and interest is compounding continuously, so this is R. It's just now a matter of putting P, R, and N into the formula. So we would then get S is equal to 4,000 times e to the power of 9%, which is what we're given, times 6, which is the number of years. And we just get that the amount of money that we get after 6 years is $6,864.03, right? If we start with $4,000. So it's nice to compound continuously because you get a significant amount of money afterwards, right? You get more than you would get if you compound quarterly, monthly, and so on, right? Because you're compounding continuously. Right. Now, the next thing is the interest. It's just the difference between the amount that we just got and what you started with. So the difference is $2,864.03. And we've done this before. We've done this kind of exercise before. Right. So now we have problem number 4 of section 5.3, which is still continuous compounding. It's asking us now to find the present value of $2,500 that is due 8 years from now if interest is compounded continuously at the given annual rate. We have been looking at the future value. Now we want to find the present value. So if I said, let me write here at the top, future value was P e to the Rn. Obviously, if we want to find this present value, we would just make it the subject of the formula. So it would be P is equal to, divide everything by e to the Rn. So that would be S over e to the Rn. Another way to write this would be S e to the, this exponent is in the bottom, so it becomes minus Rn. Okay, so if we do that, we would find that we start with, or we end up with 2,500 during 8 years. So this is the future money. So this is 2.5. The interest rate is 8% or 0.08. And then the number of years is 8 years. So we just plug in those values to find P. And if we do that, we'll get $1,318.23, which means that if I invest $1,318.23 now at 8% compounded continuously, I will have 2,500 in 8 years. Okay, right. Now, the next problem is problem number 8, which is asking us to find the effective rate of interest that corresponds to the given annual rate compounded continuously. Now, just like we did nominal interest rates and compared them with the effective interest rate, we want to also compare effective interest rate and continuous interest rates. And just like they had a similarity in the formula, we now know that the effective, let me write a little bit better, effective interest rate is just equal to e to the continuous interest rate and then minus 1, right? So if we want to compare these two interest rates, this is the formula that we will use, right? And I think you might have seen this somewhere in the lecture recordings or in the slides or in your textbook. This is the formula that we will use. So we want to find the effective interest rate. This is what we want to find. We are given continuous interest rate of 11%, so this is 0.11. So we just plug that in. R effective equal to e to the power of 0.11, and then we minus 1. So we go and calculate that. We will find that this is equal to 0.1163, and this is a decimal. If you were to make this a percentage, you multiply by 100 and then you get 11.63%, right? So 11% that is compounded continuously is actually effective to 11.63% compounded annually. Okay, which is quite nice, because if someone says, I'll give you 11% compounded annually, or 11% compounded continuously, you are obviously going to choose the continuously compounded one. Right. Is everyone okay? I feel like I've been talking to myself for quite a while. It's just that I wanted to get to the end. I have one more question left, but are we still together? Excellent. Okay. Right. I will do one last question before we close off the session. Right. So this is, I think, problem number 12. Let's see. Okay, yeah. Problem number 12. It is asking us to have a look at a trust fund question, which says a trust fund is being set up by a single payment so that at the end of 30 years, there will be $50,000 in the fund. If interest is compounded continuously at an annual rate of 6%, how much money should be paid into the fund initially? So this is just a question that is helping people. Well, it's for helping someone to make a decision. How much should you put down now so that you can have $50,000 in a fund at the end of 30 years if you have an interest rate of 6% compounded continuously, right? So you just need to find out how much money you need to put in now, like a lump sum you need to put in now so that you get a much larger lump sum of 50,000 in the end. So now means present value. So it's just the same calculation of present value. So present value of continuous, which is present value equal to future value of e to the minus rn, right? Because we already know that the future value is equal to the present value times e to the rn. But if you make this a subjective formula, we then get to this point. So now this is a present value calculation. So how much money should we put in now to get 50? Is it 50? Yeah, it's 50,000. So e to the power of minus. The interest rate was, let's have a look, 6%. So 0.06 times how many years? 30 years. So we just do this calculation. And then can I just get an indication from the chat room what answer you get for that calculation? What is the lump sum you must put in now to get that 50,000 if you compound 6% continuously for 30 years? $8264.94. That is exactly correct. So 8264.94. Right. So you need to put just over $8,000 for you to get $50,000 for 30 years if you compound for 6% continuously. So, and I think the solution says the same. Yeah. Okay. So that is correct. And at this juncture, I would like to say we're at the end of our session. I'm open to answering like questions for the next 5 minutes if someone has like any issues or follow-up questions, but otherwise, I will stop the recording if no one has a question, and then we can chat over email. So the floor is open. Okay, so one question is, where will we find the recording afterwards if we want to look back at the session? So this is actually my first Teams Collaborate session. So I want to see if it will give you guys a download link. If it doesn't give you a download link, I will just download it on my Teams because it is hosted on my Teams, and then I'll upload it. We used to upload them in, well, they used to automatically be uploaded in the recordings in Blackboard Collaborate, but since we're not using Blackboard anymore, I think I will just put them in the support forum. So if you don't have access to it, maybe you can actually help me and tell me sometime tomorrow morning if you have time. If your Teams tells you that there is a recording that's available that you can download. If it doesn't do that, I will just download it and then upload it myself in the student support forum, which is where I'll also upload the PDF documents that we look at in the sessions. All right. Okay, I'm going to stop the recording now.